This is our first lecture in CS116. This course is important for many majors. For computer science and engineering, it's like a core fundamental course without which they cannot proceed with their study plan. For other engineering fields, yes, it is similarly, not identically, but it's pretty important. The point is that in modern days and today, for example, if you say to someone that you finished a degree in engineering, say industrial engineering, or even some technical field like architecture, then they would likely expect from you that you have some knowledge in programming. Similar to the fact that it would be very surprising that you don't know how to prepare a document using Microsoft Word, or you don't know how to manage some files in Windows. It would be similarly surprising if you don't know how to manage a simple program. So you need to know how to write a program using, the language of choice in this university is C. It is an old language, but it is a very powerful language. And by the time you get yourself familiar with C to write small programs, then other languages become rather easy. In the same time, C is a very important language due to historical reasons. It's like the mother of all languages, the mother of all important languages, including C++ and Java. And yes, comes from JavaScript, which is the most popular language because it's the language of building websites. Python is a very, very popular language because of the rise of artificial intelligence and machine learning. And they were all either built upon C or were influenced by C. Not to mention C++, the ultimate super powerful programming language for building applications which cover the whole stack. It moves from system applications to user level applications to even web applications. So C is a very, very important and influential programming language. The point is that, to tell you a small anecdote, computers are the physical hardware you go and buy from the store. Without operating systems, computers are pretty useless. So we know that the most important computer hardware piece is the CPU. But without an operating system, there is no much use of the computers. And to build software, to be able to make better use of the computers, then you need a programming language. And historically, the most important operating system is Unix. It's hardly used today. And the most important programming language is C. Interestingly, they were both made by the same person. Yes. He's a computer scientist who died several years ago. Yes, so let's start using our slides. Can you see the slides? Just need one signal, please.
Yes.
Good. Yeah, we will be sharing the slides with you every now and then. I mean, they will be made available to you, and the platform you will need, you will be consulting to download the slides is mygju.com. I want to be using Teams for sharing the material for your info. So we won't be having a Teams group. If I'm sending you a message, it would be officially through the email. If I'm uploading material, it would be officially through my GJU. So, just for your info, there is another course called Computing Fundamentals. It is taught to students in logistics, accounting, business, translation. So those students take another course which has the same name, Computing Fundamentals, but it has a different number, Computing Fundamentals. It will be CS116. It has different content. Yes. It's like the easier version. So let's ask ourselves first, what is programming? Programming is giving instructions to the computer. And what is a program? A computer program is just a set of instructions. This set can be small, like a small set of instructions responsible for performing a simple task, or a long set of instructions responsible for performing a complicated task. It could be something like making a small program which receives two numbers, adds them, and gives you the sum of those two numbers. So our program can be a very small, tiny program, which I provide to it as input 5 and 7. It adds 5 and 7, it produces 12, and then it gives me back 12. And it could be a very sophisticated, lengthy program that handles, for example, a sophisticated task of receiving the list of all students along with their grades, names of students, grades of students, and university ID, student ID. And it gives you, for example, the average of the grades and the mean, the median, the standard deviation. It also generates maybe a curve, also gives you back the student, the name of the student and the ID of the student with the highest grade, with the lowest grade, the number of students who passed, the number of students who didn't pass, and so on. So it makes a lot of tasks. Of course, this program is bigger than the program which only adds two numbers. However, if we are interested in this or that, we want to benefit from our computer and to give instructions to our computer. And originally, to talk to your computer, you need to know the language of your computer. The point is that computers out of their factory, they don't speak any language apart from that extremely hard language called machine language. It's the language of zeros and ones. It's the language of, it's a very inhuman language, a language that is not human friendly at all. And the point about that is that computers are made from digital components. So CPUs, the central processing unit, is made from digital components. So things which are either on or off. So it's either 0 or 1. So the instructions which can be formulated to give instructions to the computer to achieve tasks using this computer are to be written in this way, zeros and ones. But computer scientists recognized long time ago that this is a very inhuman way and it's extremely cumbersome. What can be done to improve the situation? They thought that why don't we build a software, a program that receives from us, from human beings, receives a human-like program and then translates the human-like program to zeros and ones, which the computers can then understand. So we need to bring the computer to a better state of understanding our language. So yes, they've made it long time ago, like 50, 60 years ago, and they built a translating unit. This translating unit is just another program. It's called the compiler, and they developed languages which look like a human language, like English, for example. They developed languages like Fortran, Pascal, C, many programming languages. And those languages, they are not zeros and ones. They are human-like languages, English-like languages. So, and they ended up what? They ended up they ended up revolutionizing the whole programming experience of people. And now we have languages like C, C++, and so on, which can be written. You need to spend some time, like 1 month, learning this language instead of spending ages learning the zeros and ones. And then you can write a program, and then this program gets translated using a compiler. So originally, if you want to write a C program, you need to have a C compiler, which translates your C program into machine language. So this is how things go. I mean, this diagram here, it shows you that on the right-hand side here, we have this geeky looking boy who has 2 monitors connected and a cup of coffee, which is typical to programmers. And he's writing a program, and he wants this program to be executed on this machine. So we need a compiler. Without compilers, you cannot translate C language programs into machine language. So as I told you, C is a very interesting language because of it being so influential in the short history of computing. Computer science is not something which has been there for thousands of years, just the last few decades. And C is compact, fast, and powerful. It's closer to the hardware than other languages. Yeah, this can be a technical term, but it is not far from the hardware. It's like the scene is on top, you have the human being, and the very bottom, you have the machine. And C is not very far from the machine to the side of the human. But this is a technical term which computer scientists get to understand maybe after the second or third year of their study. And C has been a very popular language, and it is compatible with C++. If you write a program in C and you have a C++ compiler, then it should execute your program without errors. And it supports other modular programming style, like you can split your program into multiple units, and those units achieve certain tasks, and you invoke them, you call them whenever they are needed. And it is the language which was used to build many successful operating systems, to build games, to build other compilers and interpreters. Interpreters are similar to compilers, and it's the language for those in the fields of research. So it's a preferred language for building science and mathematical experiments, for building software, for artificial intelligence, for web development. It can also be fit but it is a rather technical language. I mean, some people don't like C because uh, it has a learning curve, especially after you start becoming an advanced programmer. But for our level of knowledge during this course, within the scope of this course, no, we won't be dealing with that hard side of C. And C is the native language of Unix, which is the most popular it's the most influential operating system, along with its variants, Linux and BSD. So Linux and BSD were like replicas of Unix. They were built to, because Unix, at one day, it was built in the 60s, and as you write a program, you write the code behind this program. So it was written at a time where people who wrote that program, they worked in an organization, and that organization, it didn't want to disclose the code. They preferred to protect the code using the copyrights, so it remained a secret code. So some people at a group of researchers at the University of Berkeley, UC Berkeley in California, they wanted to replicate Unix. It's like you build a car without knowing how the car was built. You replicate a car. So they rebuilt Unix using C, and they did so successfully that their software became a very popular uh, backbone even for other softwares. So all of what you see, I mean, maybe many of you use iPhone. So iPhone has iOS, and iOS along with Mac OS are all built upon BSD. Android, which is the very popular operating system for smartphones made by Google, it wasn't entirely made by Google. It was based upon Linux, which is another replica of Unix made by Linus Torvalds. So it's good to know these things, especially if you are within the area of computing. So who made the programming language C? It was made by this guy to the right, Dennis Ritchie, who died in 2011. In 2011, also Steve Jobs died, but few people knew about Dennis Ritchie, who's a very influential computer scientist and programmer. But many people got to know about Steve Jobs, who doesn't know Steve Jobs? Yeah, he's the founder of Apple and one of the leading pioneers of the computer industry. Steve Jobs. Yes. C as a language, because of its popularity and widespread, it passed through several standardization phases. One of them took place in 1983 by the American National Standard Institute, acronymed as ANSI. So they produced ANSI C, which is known as C83. And then in 1990, another standardization phase took place, producing C90, and another phase took place in 1999. I think another phase took place also. So C is still handled. This keeps the language alive and updated. So languages, this is just to show you what compilers do. You can see this hierarchy here. There are very high languages, very high, that is very friendly to the user, very high level programming languages like Python. It's more like plain English. And there are high level languages which are a bit closer to the hardware, sometimes called mid-level languages, but they are still classified as high-level, like C and C++. And if you go down, there is a language that is very close to the hardware. It's very similar to the nature of zeros and ones. It's called assembly. And finally, you reach the machine language. The machine language is just binary stuff, zeros and ones. And in order to move from a language that is closer to the human being, English-like, to zeros and ones, you need a software called compiler, which translates your code into machine code. And finally, that machine code can be executed on the hardware. To the right, here you can see that if you want to start your journey learning C and coding in C, you need to have one of those software packages, which I think all of them are available for free. You don't need to pay anything. So you need to download either Visual Studio made by Microsoft or Visual Studio Code. Don't confuse them, they are two different things. Code blocks, NetBeans, Notepad++, Eclipse, all of these are options. I think the friendliest to you is the Microsoft Visual Studio, the one which is currently being used in the computer labs here at GJU is NetBeans. Even also, if you are a user of Mac OS, then you have these options. You can also use Vim, VIM, which is for the very geeky ones. If you are a beginner, then yeah, avoid it. Hopefully we can write a program in this lecture. So this can be considered as our first program. If you write include stdio, you need to write the following lines. So within this block here, you need to write the following lines, hash, and sometimes called sharp. It's this symbol here. Hash include, sorry, stdio.h. std is an acronym for standard, is a short for standard. IO means input, output, standard input, output. stdio, this is not studio. So include stdio.h, because this is a file actually, and just like files have extension like myphoto.jpg and myfile.doc and mytable.xls for Excel. So this is a file and it has the extension H, and H means header. This is a header file. We will skip what it means to have a header file, but this is just a header file, and I want the information in this header file to be taken into consideration in my program. So please consider this file as part of my program. I am about to retrieve information from this file. And when you want to include a file, then you should use these angle brackets. We will be using many brackets in C, just the usual brackets, curly brackets, square brackets, and angle brackets. So here in this case, we've got the angle brackets. And then we write the following line, int. Int main void. Int stands for integer. Just take it as it is now. Main is like the title. Our program starts execution from here. When the operating system, which is the responsible part for executing our program, when it starts executing our program, it starts from the beginning of main. So main as you can see after the word void, here you have a curly bracket that is only closed there. So the curly bracket is opened here and it is closed there. Enclosed between those two curly brackets are 3 lines. Those 3 lines are the contents of my main. So they are the contents of my program. Whatever is going to be executed is going to be executed here. What this means will be postponed to later discussion, but consider this to be like the heading of the beginning of my program. My program is labeled main, and this is always the case. Sorry again. In the first line, we have slash star, and then some writing, then star slash. Don't confuse slash with backslash. And whatever is being enclosed by those slash star slash can be anything. You can write anything here. And as you can see, it is colored in green. This is not C instructions. This is whatever comment you would like to leave. It's called a comment. My first program, you can leave your name here, date, time, any comments you would like to leave here. When the compiler looks at your program and wants to translate this program into machine language, the first thing it does is that it omits the comments. The comments are removed. Print F. So it's printf, it's not print. So printf, why the letter F? We can discuss this later, but here you have our first C instruction, printf, and then star, and then there is an opening of a bracket, and then there is a statement surrounded by 2 double quotes from here and there. The statement says, Assalamu alaikum. And then it is concluded with backslash n. Then the brackets are closed. Then we've got a semicolon. What else do we have? We have then the word return 0. Return 0 is like, I finished writing my code. I am about to leave here, and I'm sending a signal to the operating system that everything is okay. It's like a white flag. Then the curly brackets are closed, and my program finishes here. My program here comes to an end. In the writing there, here and below, the next slide, you will see an explanation similar to what we've discussed. It's good to pay attention to the following facts. C is a case-sensitive programming language. So what is capital should remain capital. What is small letter should be dealt with as small letter. They cannot be mixed or confused. This would raise errors. All the lines within main must end with a semicolon. All the programming lines within main must end with a semicolon. A comment like this is excluded. It's not a programming statement. The execution of our program starts from the beginning of main and ends by the end of main. And those curly brackets here signify the beginning and end of our program. So this just explains things again. And let's go back a few slides. as you see here, main is, as a thing, we call it a function. So the function main here, it begins here and it ends there. And the word void, which we postponed, what it means, the fact that the two brackets after main are left empty, it means that this function takes no input. I am sending a message to the compiler that this function takes no input. So it's healthy to write void, which means that my main function takes no input. This is an example of a function just for you to review what functions mean. For example, if we have f of x equals x squared plus 1, this is a mathematical function, and in programming, a function is pretty similar. But this function here, it receives an input, which is x, and it produces an output. In our case, our function main doesn't receive any input, as you can see, but it returns 0. It returns an integer, int, of value 0. And this is just a standard, which keeps repeating throughout the semester. It means that the program ended successfully. Yes, this is just a quick review of what functions could mean. The statement, Assalamu alaikum. What would printf do to the statement, Assalamu alaikum? So in the beginning, recall, in the beginning of our program here, we included this file into consideration, stdio.h. Originally, the language C doesn't recognize the command printf, although we still haven't talked about what it does. But since printf is not identified by C, how can we make it to be identified? We just need to include stdio.h into our program so that it is identified, so that stdio is known and the program doesn't raise errors. Yes. So the function printf takes as input Assalamu alaikum \n, and then it gets executed. What does this function do? It prints. So printing here has nothing to do with printing on paper, printing a book, or printing anything physical. Printing means displaying on the screen, on the output screen. The output screen is a black screen, typically black screen, which can only take text. So as input, the function printf, it takes as input this string, this statement, Assalamu alaikum, and then we've got \n. \n means that even if you print another thing, if you have another command of printf to print another thing, it would appear on the second line, because \n means whatever you printed on the screen, please let it be followed by a new line. Let it move to a new line. So let's open Visual Studio. This is how, when you've just opened Visual Studio, this is how it looks like. You create a new project and you choose console app, but you first choose C++, and you choose console app from the right here, and you click next. Our first lecture. and you create this thing. So here I've got some C++ code written. I would delete everything and would start from scratch, include stdio.h int main void. What we are using now is called an integrated development environment, IDE. And this helps you, this provides a lot of facilitation to you as you write code. It gives code coloring, as you can see here. It closes the brackets once you open them. Printf, I would like to put this here. Assalamu alaikum. Let's remove \n for a while. Printf assalamu alaikum. Then who would like to remind me what shall we write here?
Return 0.
Correct. How to run our program? You see this green play button. You click it. And that's what we have here. Of course, just ignore the trash text here. This is the actual output. So between two brackets, our program works correctly. Let's close this and write printf Guten Tag. Guten Tag. Should it be written like this or two words this way? Huh? Our fellow, please correct me if I'm messing.
It's all right. It's right.
Good. Guten Tag. Sie sind verbunden mit dem Mailbox von. That's when someone doesn't pick up your call. Huh?
Yes.
Yes, and you miss few euros from your balance. And yes, so assume that someone writes a program which looks like this, and you run it. Remember that we have not used \n. This is how it looks like. So, assalamu alaikum, guten tag, they are stuck to each other. Of course, that's not what we want. So how to solve this? You just use new line here. It would break the two statements into two separate lines. So I hope that new line is now clear what it does. Okay. This is another program. And in this program, we are introduced to the notion of variables. So in this program, we are dealing with variables. Our first variable is called x. Our second variable is called y. Our third variable is called z. Not only did I define those variables, but I also specified their type. So we've got x, y, and z, three variables which can only take integer values. Integer means whole numbers. So you cannot store in x 2.5. X can take values like 0, 1, 2, 3, 4, -5, -10, but not 2.2, not 3.1. This cannot be stored in neither X, nor Y, nor Z. None of these. Because all of them are of type integer. And that's what this line tells me. Int X. It tells the computer that define X as a variable of type integer. The same for Y and Z. And in the subsequent lines, we give values to X, to Y, and to Z. X is 7, Y is 3. And Z happens to be the product of X multiplied by Y. The product of, now we, in our printf line, in our printf statement, we write the product of 7 and 3 is %d. That's weird. What's this? This is just a placeholder for what comes after the comma. See here, we used double quotations, and double quotations were closed there. This needs to be fixed, actually. Let me fix this. Yes. So the double quotations were closed there, and you place a comma here, and then you have Z. What happens is that Z will be placed there. Z will be filling this placeholder %d. So to the right here, you have the output, how the output would look like. The product of 7 and 3 is 21. Let's try this. Let's write this in our writing area here. Let's remove this stuff. Int X, int Y, int Z, X equals 15, Y equals 13, Z equals X times Y, printf, the product of 15 and 13 is %d, and a new line, please. What should go here?
Z.
What shall I? Z, correct. So what's 15 times 13? 195. Huh? So this is how our program look like. This is how our program looks like. I hope you're seeing such things for the first time, and I hope that programming is being interesting to you, is showing you a nice face. Interestingly, I would like to tell you that as you use C, you are not obliged to use integer all the time. C can also deal with variables which can take fractions and take decimal numbers, decimal points, and can deal with many other things. However, as we go on, we get to learn about these things. For integers, you either use %d or %i as you want to print them here. There are other data types like character, float. String comes at the very last lecture of this course. In the later part. If you want to declare a variable of type integer, you need to you need to write it this way. If you want to make X into a character can only take a single letter, like W, Q, G, whatever. If you want to declare a floating number is just a real number, something which can take fractions. You use the float keyword. Multiple declarations on the same line are also allowed, like to write int x, y, z, or float a, b, c. That's also okay. But as you name your variable, pay attention to the fact that things are case sensitive in C. So a capital X is different than small x. Dollar signs are not allowed whatsoever, but underscores are allowed. A name of a variable can contain a number, but it cannot start with a number. And you cannot use a C keyword as your variable name. So you cannot call your variable int. You cannot call your variable char or long. So what does long mean? Long is just a big integer. So when you declare x as an integer, it can take certain amount of numbers. But if you want to store a bigger integer, then you use long. So the first line here declares an integer. The line then here gives a value to the integer, but it's also possible to declare a variable and give it a value in one shot. This is called initialization. And here I am initializing pi to become 3.14. I gave the variable name pi, which is of type float. A variable called x of type character stores this value, which is a single letter. Int x equals 5, y equals 3, z equals 2. That's also possible because multiple initializations on the same line are also permissible. Here is a small quiz for us. So what's wrong here? What's wrong in the first line? Who would like to answer?
I can.
I couldn't hear you again. Please. What's wrong in the first one?
There is no semicolon.
Correct. And what's wrong in the second one?
The dollar sign.
Correct. We've got questions. We've got Abdullah. Yes, Abu Znaid.
Yes, doctor.
Do you have a question?
No, I wanted to answer.
Just go ahead and answer. I mean, don't wait in the queue. What's wrong with the third one? The third one has two issues, actually.
Can I answer one of them?
Sure, please.
I think we must use char instead of integer.
Correct.
Yes, and I'm not sure about the second one.
Well, the second one is that int is written with capital letter, which is wrong. Okay, what's wrong with the fourth one?
It's not an integer and it's written in a capital letter.
Correct. So the value is not an integral value. It has a decimal point and a fractional part. And the keyword int is written with capital I, which is incorrect. What about the fifth one?
Capital C.
Correct. What about the sixth one? Actually, the sixth one, just to cut it short for you, the sixth one is okay. There is literally nothing wrong about it because you see it's declaring X to be character, char, and then it is assigning to X the value 3 with 2 single quotes. So I am dealing with 3 here as a letter. Later we will understand that every letter, every every key on the keyboard, every printable key, has a numerical value. So the numerical value of 3 actually is 51. And what about the last one?
Doesn't
Two
have the
issues here.
semicolon.
Missing a semicolon and using capital
Capital C.
letter. Yes, correct. Naturally, when we have variables, then we want to apply arithmetic operations on these variables. So yeah, assume that you've got A and B with these values 10 and 20. You can add them, subtract them, multiply them, and divide them. You can divide as long as the divisor is not 0. And there is that operation which we will be using in this semester, but perhaps you don't really use it outside the class, is called the modulus operator. The modulus operator asks you about the remainder of the division. It's not about the result of the division. So yeah, don't get confused, please. So for example, if you want to divide 10 by 20, if you want to divide 20 by 10, if you want to divide 20 by 10, obviously 20 is divisible by 10, right? So 20 is just 2 times 10. But what about if you want to divide 25 by 10? Is 25 divisible by 10?
No.
No, it's not divisible. So not divisible means that there is a remainder. In the case where we were dividing 20 by 10, we didn't have a remainder. So the remainder was 0. 20 by 10 is just 2, and the remainder is 0. But 25 by 10, then the remainder is not 0. The remainder is 5. This operation here, which looks like a percentage, it asks you about the remainder. So 25 divided by 10, it produces a remainder of how much?
5.
Correct. 25 divided by 5 produces a remainder of how much?
0.
Correct. There are also the operations of increment and decrement, double plus and double minus. We call it plus plus and minus minus. So A plus plus is just 10 plus plus, which causes 10 to increase by 1. It becomes 11. And minus minus, it means subtract 1 from A. A was 10. After subtracting 1, it becomes 9. What happens if you declare a variable to be of type integer and then you attempt to store a fractional part in it? Like if you declare x to be integer and you attempt to store 2.1 in x, what happens is that that 0.1 thing will be chopped away, will be ignored, and only the integral part, which is 2, will be stored in x. Okay. Let's consider the following problem. And problem here, let's consider it positively. It's not a catastrophe. It's something interesting we want to tackle and solve. How can we write a program to calculate the area of a circle, a given circle? How can we compute the area of a given circle? Here we have the area defined as pi times r, which is equivalent to pi r square. Which values here are integers and which values here are floating point numbers?
The pi
What do
is
you think?
float and the r is
Correct.
integer.
Well, r can be integer, can be float. It's up to you. But as you multiply a floating point number, let's say that r is an integer, and you multiply a floating point number with an integer, what do you usually get? You get another
Float.
floating point number. So the area needs to be a floating point number, pi needs to be a floating point number, and the radius can be a floating point number or an integer. So here is a program which calculates the area of the circle. As you can see that those are like cliches, which we keep rewriting, and rewriting. Include stdio.h. This will be written all the time. Int main, and we have not written here void. We didn't write void here. It's not for any particular purpose. This is just to show you that main doesn't receive input. If you wrote void here, you are emphasizing it so explicitly that main doesn't receive input. And if you leave the two brackets empty, main doesn't receive input. In other words, those two things are equivalent. Two ways of writing the very same thing. Just a second. Yes. Yes. So we declared two variables here. The first variable is radius. You can call it r, you can call it radius. And as you can see, our fellow Professor Ahmed Barghash, who composed those slides, decided to make the radius to be float. The area also needs to be float. You can introduce a third variable called pi. It's up to you. So the radius here is 3.1. The area is 3.14, which is pi multiplied by radius multiplied by radius. This is equivalent to pi r square. And then we print the area. Area of circle is, colon here, percentage f. What is percentage f? Percentage f is a placeholder for a floating point variable, which will be printed, which will be mentioned after the colon here. So it is the variable area, which is of type floating point, float, will be printed here. Return 0. Shall we write this program? Shall we proceed first and see if we have time to write this program? So let's keep this here. Let's take this program as is, copy it, and go to. Is the code being written here clear to you?
Yeah, it is.
Yes.
Good. I mean, the font is reasonably clear. So here is our program. As you can see, I mean, if I want to change this, I want the radius to be 5.5. 5.5 times 5.5 times 3.14, that would be the area. And you run the program and you get the output here. What a huge circle. This is the output here. So far, so good. Are things going well with you?
Yes,
please
Yeah.
ask Ali.
Doctor, and last time we used percentage D, now we use percentage F. Why?
Yes, good question. Because the variable to be displayed on the screen is area. Area will be placed instead of percentage F. Area is of type float. It's not of type integer. Percentage D or percentage I are used for integers. But area is not an integer, it's of type float. So percentage F is to print variables of type float.
Why
Yes.
is float?
Float is a variable which can take decimal point followed by fractional part, like this. Like this thing here.
Okay.
But integers can take only whole numbers.
Doctor, are you gonna send the recording على من وين؟
The recording of this lecture will be made available to you perhaps later this week or early next week. It will be made available to you. I will send you a link, an email containing a link. You can reach the recording either through a YouTube channel or a what's it called? Microsoft Streams. Okay. Another example which would conclude our lecture. So this example gives you two variables, A and B. A is 25, but it is an integer. B is 2, and it's also an integer. C and D are also 25 and 2, but they are not integers. They are floating point variables. Floating point variables can take fractional part, as you can see here. Then I put an equation between two double quotations and then execute the equation here in the printf statement. 6 plus A divided by 5 times B. And this shows you here in the comment what it actually means. Then you've got another line of printing A divided by B multiplied by B, C divided by D multiplied by D, and the negation of A. This is an interesting example. I'll show you quickly what the output would be. And in the next lecture, we will discuss it with more detail. This concludes our lecture. Do you have any question?
دكتور ايش كان البروجرامينج نسيت ايش اسمه اللي استعملناه بشوي.
Visual Studio. Microsoft Visual Studio. في واحد ثاني اسمه Visual Studio Code. لا تلخبط بينهم لأن كل واحد له طريقة بالتنزيل والتعامل معه. في الفيجوال ستوديو أسهل عليكم. موجود بالسلايدات وموجود بالفيديو هذا راح تشوفه. في أسئلة؟ Habt ihr Frage? طيب الله يعطيكم العافية. محاضرتكم هذه هي المحاضرة الوحيدة الإلكترونية إن شاء الله. This is the only electronic lecture we have. The next lecture will be a usual face-to-face lecture in the lecture room إن شاء الله. الله يعطيكم العافية بأمان الله.
الله يعافيك.
يعطيك العافية.
الله يعافيك.
مع السلامة.